stadium is it?
All right.
Where is the stadium this weekend?
Up in Golden?
Yeah, pretty much. Is it in my mind?
All right. Let's run through this homework. So again, I am moving the test to Monday, Tuesday next week. Guys and girls, I would strongly urge, if you are going to miss Monday, Tuesday next week because of vacation or whatever that comes with the holidays, I get it. But don't go too long without making up that test. I mean, it was supposed to be Thursday, Friday. Sorry that I'm moving it. All the other teachers made the choice without me. All right, so problem number 43. They tell us we have this, x to the third plus 5x squared minus 2x minus 10. But then they also tell us that's one of the zeros. Yeah. Okay, so what we have to do is we want to use synthetic division. So I'm going to go negative 5 upside down. I got 1, 5, negative 2, negative 10. This comes straight down. That's negative 5. That's 0. That's 0. That's negative 2. That gives me positive 10. That's 0. Is there anybody who is not sure about the synthetic division? Because it is the big tool that you're using with these. So this verifies that negative 5 truly is one of the zeros. It's where it will cross the x-axis. How do I find the other two solutions? Yeah. Factors, okay. So this was x cubed. If we divide it through and that becomes a 0, that means I can make this 1x squared plus 0x minus 2, which in simpler terms is going to be x squared minus 2. And how would I solve that? I could square root. Okay, so I'm going to set it equal to 0. Do this. And then take the square root of each side. Don't forget the plus or minus. So my zeros are negative 5, positive root 2, and negative root 2. Root 2 is about 1.4, roughly. So that's your three solutions to the problem. So one of them happens to be a rational solution, and the others happen to be irrational. If you remember the difference between rational and irrational. Irrational, you can't write as a fraction. So if you took the square root of 2, it becomes a decimal. It goes on and on forever. It never ends. Is that okay on the first one? And then we go to, let's see, 44 is done the exact same way, but I want to skip to 45. A little trick on 45. So 44 is done the same way as this one. 45, it looks like this. 45, we have x to the fourth minus 5x to the third plus 7x squared minus 5x plus 6. And then they tell us that negative I is a solution. I was trying to help Luke on this one. I went the wrong way at first. I would not use synthetic division with negative I. What you have to think about with negative I is you have to think negative I is a solution, so what else is definitely a solution? Positive I, or I. Okay? So if you have negative I and positive I as the solutions, because they will always come in conjugate pairs of each other, meaning opposite sign pairs, that would have been related to if I were to have x squared plus 1 equal to 0. If I solve that, I'd get plus or minus I. So this right here is what I would have had to have solved in order to get negative I and positive I. Okay? So what I'm going to do now is I'm going to take this, and I'm going to use the long division with this. So I'm not using the synthetic. I'm going back to the long division. So let's go ahead and divide it. I'm dividing by two terms, so I'm going to start right here. So what do I have to multiply times x squared to get x to the fourth? X squared. So I'm going to distribute that. X squared times x squared is x to the fourth. X squared times 1 is 1x squared. I'll just line those up. Remember, I'm subtracting these, so those are going to cancel. This needs to come down. And then I'm going to add or subtract those. 7x squared minus x squared is plus 6x squared. Okay, so I have two terms dividing into two terms. That'll work. What do I have to multiply x squared by to get negative 5x to the third? Negative 5x. Negative 5x times that's negative 5x to the third. Negative 5x times that's negative 5x. We're going to subtract, so those cancel. This is going to come down as a positive 5x. That's going to come down as a 6x squared. I think that'll work. I don't have to bring anything else down. So then you have to ask, what do I have to multiply x squared by to get 6x squared? 6, okay. 6x squared. Plus 6. Yeah.
What the negative 5x in the original part, and then the 5x that you got when you got the 5x cubed.
Oh, thank you. That's what I was just confusing myself. You're absolutely right. So that right there would have canceled with that, so that's not there. Thank you. Thank you. And that means that plus 6. Thank you. So that awesome. So that's going to cancel. That's going to give me 0 and 0. So then my two zeros are this and this. I know for sure. I have two more zeros, so I could possibly factor. So I have x squared minus 5x plus 6. Quadratic formula would work, complete the square would work, and then I think I could go, what two numbers multiply to give me positive 6, add together to give me negative 5, negative 2, negative 3. So that gives me x equals 2 and x equals 3 as my other two solutions. So my first two solutions are complex solutions, negative I and positive I. And then my other two solutions are positive 2 and positive 3. Does the negative I and the positive I show where it would cross the x-axis? I mean, what's happening with the I solution? I is usually on the z-axis, which is the third dimension. So something's happening in the third dimension crossing that axis. But when you impose it on the xy axis, you're not necessarily going to see the shifts it's going to do. Okay, so absolutely. So 45 and 46 are done the same way. 46, they want you to use 2i. So let's use the long division, or 2i and negative 2i are the solutions, and then you go from there. 47 and 48 are both done the same way as well. And then we move, that was up through, list all possible rational zeros of the function. Okay. So 49, 50, 51, 52, 53, 54. I think we can do all these all together. Okay. So all they want you to do on these is list all the possible zeros. X to the 7th plus blah, 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 plus 12. Number 51 is 2x to the 4th plus blah, 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 blah. 51 plus 8, 52. Alright, those are all the ones I really probably have to do for here. Alright, so if they want you to list all the possible solutions, so you're going to take all the factors of this over all the factors of this. So all the factors of this first particular one are plus or minus 1, and that's all you need to list. On this one, I'm going to take all the factors of this over all the factors of 1, so it's just all the factors of 12. So I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. Plus or minus 6, and plus or minus 12. All of those would be over 1, so those are all possible solutions. And then 51, I want to take all the solutions of 8 over all the solutions of 2. So I'd list this as plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, all divided by plus or minus the factors of 2. So that basically gives you 2, 4, 6, 8. Gives you 16 different opportunities. And then 52, all the factors of this over all the factors of this. So plus or minus 1, plus or minus 3, plus or minus 9, all over plus or minus 1, comma, plus or minus 3. Do what's that? Okay, so it's all of the factors of the constant, which is the non-x term, over all the factors of the lead coefficient.
Okay.
That's all it is. So if you let, and where this would become a big pain is like, let's say you had 64x to the 5th, and then your constant's 48. All the factors of 48 over all the factors of 64, you're talking 40 different factors.
Okay. So if it's just like no coefficient,
it would just be over plus or minus 1, which
so
means.
you don't have to do that.
Is that right? And then 53 and 54 are done the exact same way. And then, let's see. What does Descartes' rule of signs tell you about the number of positive real zeros and the number of negative real zeros of the function? So we're just going to go through and do this. So 79 we have f at x is equal to 3x to the 5th minus 2x squared plus x minus 1. Okay, so the first test for the Descartes' rule of signs, if you remember, is we're just going to look to see if there's any sign changes just as it sits. So I went from positive to negative, so there's a sign change. Negative to positive, there's a sign change. And there. So what can you tell me about the positive real zeros possible? 3 or 1. So the positive real zeros could be 3 or 1. Okay, remember, so it always drops to a 2. Yeah. Okay, so every time, number of sign changes, minus 2. So if you had like 5 sign changes, you could have 5, 3, or 1. And it's a tool to use. Obviously, with technology today, it's not as powerful of a tool as it had been, but that's what we're looking for. And what you have to realize is we're talking about the positive real zeros. Now here's the problem. If your zero is irrational, it's not going to work with this. Okay? Phone's away, please. Does that make sense?
So are the sign changes meaning like 5, 2, and x?
So
5, 2, and 1.
I had positive 3 to negative 2. There's one sign change. Negative 2 to positive x. There's another sign change. Positive x to negative 1. So the signs here. So you're looking here, 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 and here. Those are the signs to change. So what this finds is it's possible that you're going to have 3 or 1 crossings.
But is that 4 sign changes?
1, 2, 3. So you're going to have it cross the x-axis over here 3 times or 1 time. Okay, it's not going to just cross twice. If you found 2, then there's a third one that you need to look for. So then the other way is I'm going to plug function of negative x in. And here's the hard thing. You're taking a negative and you're plugging it in. So you have to realize that that negative x is going to be raised to a certain power. So you have to go through the math of it. So you have 3 times negative x to the 5th minus 2 times negative x to the 2nd plus negative x. And I know now I'm in the way. So I have that. So if you were to take negative x and raise it to the 5th power, so you get negative, 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 is the answer going to be positive or negative? It's going to be negative. So this actually could be rewritten as negative 3x to the 5th. Does that make sense? Sometimes it's hard to wrap your head around what's going on with that, but you're plugging something in, you're doing the mathematical function to it, it's either going to come out positive or negative. What is negative x squared? Does that stay positive or does it go negative? Okay, so what happens here? It stays negative. Good. So negative 2x squared, and then positive negative x minus 1. Now we're looking for sign changes. What do you know? There is not a sign change. So there are no negative real solutions. So on the xy axis, it's not happening over here. So where would that tool be helpful? Where would that tool be helpful, do you think? Think a little deeper. Think about the problems that we just did back here. What am I eliminating by seeing that there is 0, negative, real zeros? What am I eliminating? What do you think? What's a negative 0? Those are all the possible zeros of each function. What are the negative ones? Not odd. Not I. So this listed all of the possibilities of our real solutions. Point away, please. This is the possibility of all of our real solutions. Positives and negatives. So then on the next step, on this problem right here, we saw that with the green, we have 3 or 1 positive solutions. So that means on the xy axis, we have 3 times it can cross over here, or 1. But what does this mean? Which ones am I eliminating from that? The negatives. So what you're doing with this piece of thought process through this problem is you are eliminating half of your possible zeros to go and divide through. Okay? Is this right here, let's say we were doing that problem and we were going to use all of those factors. If you were able to find out that only half of them are going to work, what did that truly do to you with the problem? Meaning, this is raised to the 4th power. So the possibility, you will have 4 solutions to the problem. Now, you could have a solution that happens multiple times. You could have a solution that becomes complex, meaning it's imaginary. But let's say I knew that, let's say this was the problem that we were working on. These are all the possible solutions. But now I found out that it's not going to happen over here. So now I can go through and say, well, none of the negatives, I wouldn't have to worry about the negatives at all. So that's half the number of synthetic divisions you'd have to do. So if you knew that a problem you're working has 4 solutions, and you knew that it could happen 3 or 1 times in the positive, well, now you're only synthetically dividing 8 possibilities versus 16 possibilities. So you've kind of cut your work in half. But what's tough is you're relying too much now on a calculator, and you're like, okay, I'm going to find where it's crossing the x-axis on the calculator. So you're allowing the calculator to go through the mental math that Descartes did way back when. And this kind of math was math that took place up until the late 80s, until the graphing calculator came out. And then the graphing calculator came out, and it's a good tool, but the unfortunate thing is it took some of the problem-solving process away from you because they put it in your hand. Okay? Right now, I'd say almost everybody in here has the capability of getting onto the internet using their phone or their iPod. Would you think that's an okay thing for me to say about this class? Okay, if you're the one kid who doesn't have it, we don't need to exploit you. But right now, have we made you a better problem solver because you have the access to everything now? Are you smarter than they might have been before. And it's hard to tell. It's really hard to tell. I think yes or no could be an answer, but what?
If you were taking, like, if the phone were taken away from us, then we wouldn't have that. Like, we would still be smart, but back then we didn't have the information with us all the time.
Yeah. So they would actually have. I think two things are going to happen here. Hang on, get your comments in. Two things are going to happen here. One, you have the instantaneous access to information, which could be very good. Okay? Like, I have an app on my phone right now that it's WebMD. And if my child had something wrong, okay, child has fever, 103. Okay, do these symptoms persist? No, 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 yes. Okay, what about these symptoms? Nope, nope, no, yes. Solution, contact doctor in the next couple of days. Here you go. Is that better for us, for society, or should we saturate people that show up to the doctor every time their kid's got a little snot hanging out of their nose? It depends. I mean, if you have a life-threatening disease, let's see, child hit head. Is one pupil bigger than the other? What is pupil? Oh, the black part in the eye. Yes. Call 911 now. Okay, that's pretty obvious. I better call somebody because my kid's got a major concussion, it damaged a major blood vessel in their brain, and it's not allowing their eyes to work appropriately. That's a major medical emergency. They need to go in with a drill and go into that kid's head. Okay? Well, I'm just saying. Oh, it's crazy. My child bumped head. My child has a bump on their head. Is one pupil bigger than the other? No. Do they have a fever? No. Are they confused? No. Is it hard to wake them up? No. Do they have a chronic headache? No. Okay? And then next to it will say any of these things. If you notice in the next 2 to 3 days something happens, the possibility of a concussion is a big possibility. Have your child see the doctor now. Okay? Don't call 911. Is that good for us as society? I think it could be really good. But where it's really bad is, let's say you go to the doctor going, I got this pain right here, and you're like looking at your phone going, the commercial on TV said I should get this.
Or even WebMD says I have this.
Yeah, we have this. Yeah. So you're going to go to the doctor and say, I think you should prescribe me this. Because I heard it on TV. And the doctor says, do I have the degree in medicine? Or do you? So that becomes, it's a delicate balance. Are we smarter that we have instantaneous information in our hands? We could be. We could make better choices as society. Okay? I remember years ago when people started getting medical insurance, it'd be like, you hear people saying, yeah, it costs me $50 a month to have my kids on this insurance, and I have to pay $10 when I go to the doctor. You had lines out of the doctor's office all day long. Why? It was cheap. Like, sweet, let's go to the doctor because it's cheap. Now, you go to the doctor, you kind of think about it a little bit, going, looking at your kid going, well, suck it up. Go back to bed. I did it this week. Thursday, I'm walking into a meeting. I get a phone call from my daughter's elementary school. Hey, just want to let you know your daughter threw up at school today. She's in the nurse's office. I said, did you try to get hold of my wife? Yeah, she wasn't available. She didn't answer her phone. I said, okay. I can get there by noon today. It's like, I don't know, 10. From walking into a meeting that I had set up. And the person had driven from Arvada in snowy weather to get here. And I'm not going to cancel. So I'm thinking, and so I just sarcastically, I'm sure you guys could see me saying this, tell the nurse at her school, tell her to brush her teeth, go back to class, and suck it up. Yeah. Really? You think your daughter should do that? She barfed. Kid puke. She have a fever? No. She's fine. I mean, I'm serious. So should I react and say, let's go to her doctor right now because she barfed? No, I just had a girl in the med class. You didn't even see her. She barfed in the back trash can today. Yeah.
Oh, wait, what were you worried
I just think she had an upset tummy.
Yeah, I was like,
probably
Ebola
Ebola or something.
about?
That's what we were learning about.
No, she goes to the trash can. And so I pick up the trash can and say, come on. And I walk around out the door.
Is that why the trash can is in the middle of the hallway?
Yeah. There's barf now.
Was it in the middle of the presentation?
Yeah, about 15 minutes in, I guess.
Really?
Hey, you guys didn't even know. How's that good? How's that good getting around? And I said, can you make it to the girls' restroom with it? She goes, boom. And she went. She came back about 10 minutes later. She goes, can I go home?
No, you can't.
Sit there, suck it up. No, but so what happened with my daughter between Thursday to Friday night? Friday night, actually Saturday morning, like at 2 a.m., she says her ear hurts really bad. Well, she's got an ear infection. Now I gotta go to the doctor on Saturday, which it wasn't too bad. There wasn't a lot of people there because the roads already sucked. So we get there, but of course it went from the $50 copay to a $200 copay because we were at the convenience Saturday session. So I could have saved myself $150 if we just would have went. It's all a ploy with the medical. They'll show up on Saturdays. We'll be able to make so much more money. Yeah.
Take off Fridays.
It's alright. She'll be fine. She's got amoxicillin. Take that for 10 days. She'll be fine. Yeah. Heck yeah. Actually, went on Friday too. Yeah. I was kind of frustrated that the nurse called me, like, come pick your kid up. She barfed. No fever. She's fine. All right.
I broke my ankle in the hallway.
Sarah was such a class.
You didn't go. She fell asleep and I got up and I broke my ankle in the middle of the hallway. I started crying.
All right. So I want to make sure you guys get that assignment done. We'll go over a little bit more of it later. I have this lesson we're going to do. I'm going to take 2 days on for today.
PG.
Is that okay? So I want to start it today.
Is your other daughter okay?
She's fine. They both hate me, but hey,
They don't hate you.
they do.
No, they don't.
They really do.
That's not true.
Why would they hate you?
I don't know. That's what I can't figure out. How? All right. So let's do a small little lecture. I got a few minutes. I think we can get through it. Okay, so we're now jumping into rational functions. And a rational function is pretty cool because, well, it's cool to a math teacher, to a high school junior or senior. It's the worst thing on earth. A rational function is a polynomial over a polynomial. Okay? You have a polynomial over a polynomial. So I want to just hit you guys right now with terms and rules that way you can just walk through. Okay? So let's talk about the first thing. Let's talk about vertical asymptotes. Totes? No, there's a T there, there's an E. All right, vertical asymptotes. Shh, shh, shh. What is an asymptote in math? Something the line can't go past. Okay, asymptotes take place when you have an undefined term. Right there, Chief. Okay, vertical asymptote is where your graph could be undefined. So if I had a problem like this, what number will make that undefined? 2. Why 2? Yeah, it makes the 0 in the denominator a big no-no. So if I were to graph this on an xy axis, at positive 2, you have this region which our graph can't touch. You have this region that our graph can't touch. Okay? So I would say that this graph could look something like this. Could look something like that. So you have a vertical asymptote. You have a region in the graph that can't exist. Okay, so it's wherever the denominator is equal to 0 becomes a vertical asymptote. Now, I want to do this same problem, or look similar, and I want to have this. Any ideas what this looks like? It's a line. Good. Slope. There is a hole in it. That's exactly right. There's a hole in it. There's not an asymptote. So what this graph is going to look like, this is the graph. It's going to be a straight line that's at 3/5. So if this is at 1, we have a straight line. That does that. You have a hole in it at 2. Does the hole look different than the asymptote? Yeah. I mean, you have this function that's going straight across, and then it like skips over that point and keeps going. Whereas the asymptote, it goes really up quickly, or comes down quickly from that line. So an asymptote is something you can approach really, really close. A hole is something you can approach really close, but when you get to it, you like jump over it. Okay? So holes and asymptotes are a little bit different. So this creates a hole in the graph. It's still an undefined term. When you graph it, you don't necessarily see it unless you zoomed in like 40 different times. If you went to the table, you would see at 2 there would be an error, meaning it's an undefined term. So that's a hole. What about horizontal asymptotes? Horizontal asymptotes. I'm going to give you 3 situations. 2 of them have horizontal asymptotes. 1 of them doesn't. So let's say I had this. Function at x is equal to 3x to the 5th plus 2. We have a big old function in there too. And then we have 5x to the 7th plus 3. So you have 2 really big functions, one over the other. So you look at the highest exponent. The highest exponent on top and the highest exponent on bottom. If the top is a less number, then your horizontal asymptote is y equals 0, which is the x-axis. If you had something like this, let's change it to g at x is equal to 2x to the 4th plus 1 over 5x to the 4th plus 2. If the degree on top matches the degree on bottom, then y equals 2/5. Okay, so it's just whatever this and over this is. And then the third scenario, would be if I had h at x is equal to 5x to the 4th plus 2 over 3x to the 2nd plus something like that. If the highest degree on top is greater than the highest degree on bottom, there is not a horizontal asymptote. But you still need to be aware of the end behavior, which is also called the oblique asymptote. Okay? end behavior oblique. And what that means is end behavior is just like what we're talking about. When you use long division on these, you can find out what the ends of the graph approach. Okay? So, guys and girls, I want you to finish last night's homework, and I just wanted to get a start on talking about this. So finish last night's homework, which is 43 through 54, 79 through 83 on page 298. I'm not adding to it. I just wanted you to have last night's done, and then we will continue this. Is that all right?